Hi there, I'm Peter Hollemans, and I'm the developer of the CoastWatch utilities and the CoastWatch data analysis tool, CDAT. And this is a video on the latest release, version 4.1.5. So I'll talk about four things in this video. The updates to the user's guide, updates to the online tutorial course. Also, I'll show some new features in the CoastWatch data analysis tool for coral reef data. And I'll also show a demonstration of creating an animation, which is something that's not in the online course. So just to start, I've pulled up coastwatch.noaa.gov in my browser to show where you can download the software. Under Data Tools, CoastWatch Utilities, you can scroll down on this page and the source code and downloads are here. You can use the package on Windows, Linux, or Mac. Now, the first thing that I wanted to talk about is the user's guide. And even in this package, in these packages, the document that is the user's guide is a little bit out of date. And so I've created a revised version. If you just scroll down on this page right here, you'll see version 4.15, user's guide revised. And the main thing that's revised in this guide is the section on the CoastWatch data analysis tool. So it's been updated for the latest version and simplified. And the another improvement is in the appendices in the data format compatibility appendix. And it's a lot easier to read these tables now as to what data formats the CoastWatch utilities read and write. So two major updates to the user's guide. Lots of other little updates, but these are the big ones. Now, what was the online course, also linked from this page. You'll see it right here, the CoastWatch Utilities online tutorial course. This is a placeholder, so just click through. So you'll see the online course now has its own structure, which includes a search function. And so you could scroll down on this intro page and look at the table of contents and see what it is you're interested in learning about and click it. Or you can go to this search on the left-hand side, and let's say you were interested in overlay groups in CDAT. So you could type overlay group, and then you can click through to that lesson, and it will give you step-by-step instructions on how to use overlay groups. Okay, so that's the updated course format and the updated user's guide, so new documentation. So what I'll show now is a set of updates to the CoastWatch data analysis tool for looking at coral reef data. And the coral reef data I'm talking about is on this web page, coralreefwatch.noaa.gov. And so you go to the page, this is the landing site. I'll click here to view the new style homepage, it says. And if you hover over these products, you'll see the different products from Coral Reef Watch. SST trend 7-day, anomaly, hotspot, degree heating week, bleaching alert area. And what I've done is I've gone ahead and I've downloaded a couple of these data files. So I've downloaded the SST anomaly and an SST trend, and so I'll show those. So you can click on the website and you'll see a plot. And you can click on that plot and you'll see an enlarged version of where you clicked, but you won't be able to see the data values themselves and do any analysis on them or export them to a different format. So I'll show you how to do that. If you take a look at this previous page where it says data and images, I've already done this in advance, so I won't do it now, but I'll just show you where I did it. Here under this data access via HTTP server, you'll see a list of the NetCDF4 data products. And so I went through and clicked on SST anomaly, and I went through the list of years and dates, and I found data for February 8th this year for SST anomaly, and I also went and found the same for SST trend. So I've downloaded those and I have them in my on my laptop here. So what I'll do is I'll start CDAT, and when you have it installed on Windows or Mac, you can find it on the Mac under Applications, under Windows. It will be somewhere in your Start menu. And I'll scroll down, CoastWatch Utilities 4.1.5, under the bin directory. I'll double click CoastWatch Data Analysis Tool. That pulls that up. Now I'll go to my Finder window on the Mac and I'll drag, let me go back to that directory of files I had. I'll drag, say, SST anomaly into CDAT. And then you can see it's viewing that file as if you would like to open it. And I can look at the individual variables, sea surface temperature anomaly, and the mask, which is the land mask and ice mask in this case. And I'll select all of those, hit OK, and it will pop up that data. Now, what you'll see initially is a default color scale that we've pre-selected for the SST anomaly data from Coral Reef. And where you can see that and adjust it is in the preferences. So here are the preferences up here. Under enhancement, you can see a number of SST Coral Reef Watch related variable names. So sea surface temperature underscore anomaly, which is the variable that I'm viewing, has a default palette of Coral Reef SST anomaly scaled from -5 to 5. You can change that. And same thing with all of these other variables that are from Coral Reef data files. You can just look through those and see how they're scaled by default. Now, another thing that will help is if you want to make the image look like the Coral Reef Watch website. So let's look again here. Go back like this. What have I loaded here? I've loaded anomaly. So let's look at anomaly. Looks like this. Click on that. Okay. But you'll notice that there's a very specific styling of continents and grids, and I believe ice mask will show up if we were to see the poles. You can see that in the legend here, no data and ice. So how do we make CDAT do that? Well, there are a number of predefined overlay groups now. If you go into layers and into overlay here, saved overlay groups, I can just double click one of these. And if I'm using the SST anomaly data file, I'll double click Coral Reef SST anomaly, and there we have it. So it will layer on a set of saved overlays that have been designed for you. And you can turn on and off these if you want, or rearrange them. And for example, ice is a very specific bit mask that's using the data from this extra variable in the file called mask. So ice data is stored in a certain bit, and this bit mask will bring that out. In a different way, anomaly less than 5 and anomaly greater than 5 are masked using an expression mask. And you can read about that in the online tutorial course. So that's anomaly data. Let's take a look at that extra file that our other file that I have here, SST trend 7-day. So drag that in. Same thing, let's load all of these variables. Click OK. You don't see anything in that student t-test one, but if we take a look at trend, you'll see that color map. And we'll do the same thing. We'll go to layers and we'll pull up the saved overlay group that is called the Coral Reef SST trend, and it will make it look like the website. properly. We can zoom in and verify that it is actually working. And you can see on the side here, expression masks, bit masks, and coastline and latitude and longitude. So that's how you easily view coral reef data in CDAT, making it look like the website, the plots that you may be used to. Okay, there, that pulled that up. So let me go on to my fourth topic and show you a demonstration of creating a animation. And this is using a command line tool called CW Animate. Now this has been in the package for a couple of versions now, but it's not made it into the online course as a tutorial. So I'll do a demo of that. So how would you create an animation? You need a number of time steps. And each of these data files, let's think about coral reef data. Each of these data files is only one time step, so it's not going to help us create an animation. What we need to do is we need to go into the coral reef site, and other sites are available with these same kinds of servers that I'm going to show you now. And if I want to pull up a series of time steps, I'll go to Data in Images, and I'm going to scroll down to Data Access via Data Servers, West Coast Regional Node, and I'm going to click on the ERDAP server. So that will let me see a number of time steps for a data set. So if I'm going to click that, I'll click Make a Graph, and you can see that the default that it's gone to is the CRW bleaching alert area. So let's say I want to make an SST anomaly um, animation movie. So I go down to this variable. What's it going to look like? Well, each of the time steps is going to look something like this graph. Let's say I wanted to make a January 2026 animation for SST anomaly, sea surface temperature anomaly. So I've actually created a little script to do that just to help me. But I'm going to show you how I created that script. What I did is I went to the ERDAP page, I selected the data set that I was interested in, and I went up to the URL bar and I pulled just everything up to the period. So this is the data set URL that I need. So I'm going to copy that, and I'll show you in the CW Animate command line tool how to list the variables that are available in the data set and list the time steps that are available. CW Animate -- list vars, and then the URL. Enter, and it's going to list the variables that it finds in that data set. Now, CRW SST anomaly is the one that I'm interested in. So now how would I list the time steps that that variable has available? I mean, I can look on the ERDAP page and determine that too by looking at the time dimensions. But if I want to do that for an animation, I would do CW animate -- query var, and I will go variable CRW SST anomaly. Let me just check my syntax on that. Here's something that you can do. CW animate -h. Make sure I'm doing that right. Here we go. So CW animate -- query var, and then the variable name. Like this, subling the command line, and then that URL that I used before. Here we go. Okay. Now what I know is that it's going to list a lot of time steps, 14,000 of them. Made an error in that. CRW, not CWR. You can see that I even make a lot of mistakes on the command line end. So there we go. Don't feel bad if you do. So 14,000 time steps. It looks like we do have time steps for January 2026, all the way from the 1st of January here until the 31st right here. So what I can do, and I'll show this in my script, GenMovie. This is just a bash script. You can use this on Linux or on the Mac. On Windows, you would need a batch file of some kind. So I'm calling CW animate. I'm saying with this variable, I want to map it using this color map palette, which I got from CDAT. You can see over here, if I look at the SST anomaly and look at the palette that I'm using, it's called Coral Reef SST anomaly. I'm scaling it from -5 to 5 degrees Celsius. That's the scaling, that is this default scaling right here. I'm asking for the axis called time, and I'm saying that I want it to start at the 1st of January and end at the 31st of January. I'm going to title it at the top of the movie with this title, and I'm going to use a rate of 3. Now, if I look at the CW Animate help doc, I can see that rate of 3 is frames per second. It's actually FPS, frames per second. So 3 frames per second will give me a reasonable animation for a month. Okay. Then I give it this URL for input, and I give it an MP4 file for output. The output is always MP4 format. So let me run that movie generator. And while it's running, let's see how long it will take. I might show something else on the Coral Reef site. Okay. Well, let's see here. I'm running it in verbose mode. You can see it's accessed that URL. It's creating an animation along a time axis. It's got the right time steps. It's accessing the grid with a stride of 5, meaning it's subsampling every 5th pixel, so it's not downloading all of the data for every frame, which is good. Our movies generated by the Animate tool are 720 pixels high, and so that will be a subset of the full spread of latitudes that are available from -90 to 90. Because this data, I believe, is 5 kilometers. I'll have to look that up to make sure, but how could I find that out? Well, while this is generating, let's find that out. So let's see if we take a look at the info page. Oh, well, actually, the data source says 5 kilometers satellite sea surface temperature data. So that's how we found out. You can look at the file information in a raw format and find out a lot more. Who it is that we can send emails to if we have any questions, what the metadata conventions are, when the data file was created, geospatial bounds. So this is in the CDAT tool when you click the info button. What the instruments were that were used to create the data and the platforms also. I think there we are, ships, GOES satellites, Himawari satellites, Meteosat. So not just North America, but also Europe and Japan have been involved in creating this. It's a global effort. Yeah, 0.05 degrees is the spatial resolution, which is about 5 degrees or 5 kilometers. So anything else here? Sea surface temperature anomaly. Degrees Celsius is the units. 0.01 is how it's been scaled to when it's encoded into the file. These are all things that are behind the scenes, but you could use those if you were a data producer. Let's take a look here. So it looks like the video is finished. Let's watch the video. Output.mp4. Here we go. Actually starts on the 31st of December. It looks like it rounded that date to a different day, but that's okay. Minor error. If I hit play here, we get 3 frames per second, and we get an SST anomaly animation of January. Now we could do that for the whole year of 2025. All we would have to do would be to alter this script file and change the time, start and end, and the title. So that's a demo on creating animations. So I talked about updates to the user's guide in version 4.1.5, where you can get the software. Also, the online course updates, coral reef data, specific features in the CoastWatch data analysis tool, and finally a demo of creating animation. All right, well, thank you very much for your attention. I appreciate it, and stay tuned for more updates.